Good day, Doctor. My name is Laincy and I'm going to talk about the solution of question 1 in this individual assignment. In this question, we are required to sketch the function of fx equals to cotangent x, but before we can sketch it, we have to find other information that can help us to sketch the graph. First, we have to determine x-intercept and y-intercept of this function. To find x-intercept, we have to set y equals to 0 and solve for x. Hence, we will know that x is equal to pi over 2 and 3 pi over 2. The same goes to y-intercept, but we know that cotangent 0 is actually cosine 0 over sine 0 and is undefined. Therefore, we know that there is no y-intercept in this question. For vertical asymptote in this question, we know that cotangent x is equal to 1 over tangent x and tangent x is equal to sine x over cosine x. And when we see that sine x is equal to 0, we have to know that the denominator is getting smaller and smaller. Therefore, cotangent x is going to be infinity or negative infinity. Hence, we know that the vertical asymptote of this question are x equal to 0, x equal to pi, and x equal to 2 pi. Next, there is no horizontal asymptote in these questions because cotangent x is periodic and does not approach any single value as x going to infinity or negative infinity. Next, we are going to determine the local maximum and minimum point of this function that is also known as the critical point. Before we can determine it, we have to differentiate the function equals to negative cosecant square x and let it equals to 0 and solve for it. But since there is no solution for 1 over sine x equals to 0, hence there is no local maximum or minimum point in this function. Besides, we have to find the inflection point of this function that is also known as the critical point. So we have to find the second derivative of this function and let it equal to 0 and solve for it. Therefore, we know that cosecant x is equal to 0, which means no solution, and x is equal to pi over 2 and 3 pi over 2. Hence, we will get the inflection points as shown. Next, we are also need to determine the interval where function is concave outward or downward. Therefore, we have to substitute the x value in between each inflection point and vertical asymptote into the f double prime x as the table shown. If we get a positive value, it means concave upward, and if we get a negative value, it means concave downward. And hence, we will know that f is concave outward at which point and concave downward at which point. And finally, we can sketch the graph of this function by using the information in previous step. The dotted line at x equal to pi and x equal to 2 pi are the vertical asymptotes, and we can see that it is a discontinuous graph. It goes on unending in vertical direction and it gets closer to the vertical asymptote but never touching it. So based on this graph, we know that the function is decreasing on 0 pi and pi 2 pi. That's all from me. Thank you.